Hi. Here we are looking at properties of logarithms, and they're essentially the same idea behind the properties of exponents. The idea that if you're multiplying two numbers with the same base with exponents, you add the exponents, and that's kind of indicated right here. So log b, or log with a base of b, of m times n. So typically what you're going to be doing here is factoring m and n into two different factors that you're just going to express as two logs added together. The same idea behind dividing numbers with the same base and exponents, in that you end up subtracting those exponents, is indicated here. So if we're dividing m by n, we're really subtracting log base b of m minus log base b of n. And lastly, this power property means that if our log has a exponent, we can take that exponent and we can move it to the front of the log. Or vice versa. We can take this n and we can move it here if it helps us simplify a problem. So let's look at some examples. So in number 5, we're taking a log base 6 of 3x to the fourth power. Now, since this is only one expression, we are going to be taking we're going to be looking at the 3x to the fourth as and use our product property. So we're going to take log base 6, I'm not sure why this is, of 3, and we're going to add it to log base 6 of x to the fourth. And because of that power property, we can actually move the 4 to the front of the log. So we can really write this as log base 6 of 3. It's the same problem, same part of the problem, plus 4 times log base 6 of x. And we're done. Over here, we're talking about the natural log of 5/12 x. And since I see division, going back, I'm thinking about using that quotient property. So I'll be subtracting the top and the bottom, or the numerator and the denominator. So I'm taking the natural log of 5 minus the natural log of 12x. Now, a lot of people would say, hey, I'm done. I expanded it. But we can actually expand this 12x, knowing that this is really 12 times x. So I can write this as the natural log of 5, and using my product property, I can take this as the natural log of 12 plus the natural log of x. Moving down and looking at these examples, we are condensing these. So we're taking log of x and subtracting log of 9. Well, I see subtraction, so I'm going to be thinking division. And I can take the log of x divided by 9. And that's it. Over here in 8, the first thing I see is this addition happening. So I'm going to call this the natural log of 4 times, I'm going to move this 3 out front back to the exponent of 3, and I'll write it like this, 3 to the third. And I'll put the natural log of 12 there on the end. So then I'm going to solve this problem. I'm going to multiply 4 times 3 to the third. 3 to the third is 27. And 4 times 27 is 108. So I'm going to call this the natural log of 108 minus the natural log of 12. All right, we're not finished yet, because when I see this subtraction, I'm really thinking, hey, that's division. I can write it as the natural log of 108 divided by 12. or the natural log of 9.